This is Dr. Jean, dear future people. Well, why is it that people around me in 2023 are so incredibly blind? Why is it that they seem to breed mental viruses, mental mind worms in their minds? Well, I think that it is because they simply do not think through even the most basic things. For instance, measuring. What does it mean to measure something? Okay, what are the uses and what are the limitations of measuring something? Well, obviously, measuring is very important. It's very important in engineering, it's very important in economics, in science, or in medicine. Okay, there's no doubt about this. Yet measuring, like all methods, so any tool that we use have limitations and they rest on premises. In other words, we assume certain things, we base things on assumptions, and then we forget these assumptions. So that the domains that are determined by the assumptions will appear to be absolute. Why? Because we forgot them. And these domains are again based on such premises. So the main premise behind measuring is uniformity. Okay. So basically, we ignore differences, we ignore the matrix. So we concentrate on one single thing or a few single things. And we unidimensionally or posidimensionally measure something, that is, quantifiably compare something to something else. And we then think that everything else being equal, the one thing that we are measuring is going to determine some kind of an outcome. Okay, so let me put this in very simple terms. So we ignore everything except one thing, the one thing that we are measuring. And we are trying to correlate that one thing that we are measuring with a possible outcome. Okay, so with that, we ignore differences in the measurer, in the interpreter of the measurement. We ignore the differences between the measured subjects, and we ignore differences in the measuring instruments and the circumstances in which the measurement should be interpreted. Okay, so everything is standardized, everything is automatically assumed to be equal, other than the one thing that we set out to measure. Well, there is some truth and there is some practical use in this. So, for instance, no matter with what instrument, no matter who, and no matter in whom the measurement is made, if the temperature is taken and the temperature is very high, then that must mean something, right? Obviously, it's not going to mean the same thing in one person versus the other. It's not going to mean the same thing with one instrument versus the other instrument. And it's not going to mean the same thing under one set of circumstances versus the other set of circumstances. But we ignore that. You see, we make an imaginary world base of comparison reference frame in which everything else is fixed, is made standard. And we are just interested in the temperature and nothing else. Okay, so what does it mean to have high temperature, fever? The premises need to be kept in mind, or else we're going to make huge mistakes. Because if we forgot what exactly we are measuring and what we are not measuring, then we are going to misinterpret our results. Okay, so one of the many factors that play into this is permanence, relative permanence of our result. So you check somebody's temperature and then you assume that that temperature is going to be like that for a while. So it is a relatively stable temperature. It's a representative measurement, meaning that if I check the temperature the next second or the next minute, I would have the same result. So now for every measurement, we need to see what that stability is going to mean. So for temperature, let's say that for certain, or at least it is very likely, that if I check somebody's temperature now, it's going to be relatively stable for at least a few minutes. Now, if I measure the height of the pyramids or the other measurements belonging to the pyramids, for example, the length of the sides, then uh, that should stay approximately the same for centuries. Okay, and now we come to something very important that I see in my medical practice, and it is causing major problems. So I check somebody's kidney function. How stable is that going to be? So if I believe that somebody's kidney function in this particular second is, let's say, 80% of normal, does that mean that that kidney works 80% of the normal most of the time? Or even the next minute? Well, anybody who is a kidney specialist like myself, anybody thought through this? There are a few people, because I read it in the scientific literature, but most people, unfortunately, do not think through this. So in other words, if I check a temperature now, it's likely to be stable for minutes. If I check the length and the height of the pyramid, they may be stable for decades or maybe even for centuries. If I measure somebody's kidney function, er, we don't know. So let's talk about the next problem. If I measure the flow of the river, then I make a little representation of it, like a little drawing like this. And then I'm gonna assume that there's gonna be an average width, an average depth, and then I measure how long that river is. And from that, I'm gonna try to measure the volume. I'm gonna try to measure the temperature. I'm gonna try to measure the flow and all kinds of things relating to that river. Now, again, this is under ideal circumstances when I ignored a large number of factors. Now, and of course, using ideal instruments that are ideal in every situation, no matter what the temperature is, no matter if there is wind or not, I totally trust my instruments, right? They remain the same with the same precision no matter what comes. And now what I'm doing is that I leave my desk and I go outside and I look at an actual river. And what do I find? That this is far from some kind of an ideal liquid, that there is mud in it. And this mud content may change from day to day, from season to season, and there are fishes swimming by, and the temperature changes constantly, and the wind changes, and the instruments are affected by circumstances, and the measurements are going to be different. Okay, so how often do I have to make my measurements so that I get some kind of a consistent result. Okay? So this is a very simplified set of circumstances, a very idealized situation on this diagram here. And this is the actual life. And what I see here, it is that the river changes not in just one aspect, okay, like the temperature, the flow, the volume, the mud contents, the fishes, etc. Okay, but in many things at the same time. And those changes are not random. They depend on each other organically. Okay, so yes, I have to start somewhere so that I measure this, and then I measure that, and then I measure that, and I will try to correlate how these things change. For example, A changes with B, or A changes with B given C. Okay? So then, let's see where this leads us. So I look at the ocean from above. Remember this? When I look at the ocean from above, from afar, then I see something idealistic like this. And now, what I'm going to do is dive and go inside this huge mass of water. And what I see is not this very homogeneous, very uniform looking something that is on the left hand side, but I see all kinds of diversity. I'm not talking about fake diversity. I'm talking about real diversity. Different flows underwater, different animals, different densities, different luminosity, all kinds of differences. So when I measure the ocean and say, okay, here, from here to here, there is a distance, then I automatically assumed that I'm measuring something homogeneous, something uniform, so that besides the actual points A and B and their distance, everything else remains equal. But when I go inside and see the actuality of that water, I do not see that uniformity and homogeneity. I see diversity. So my measurements have limitations because with my measurements, I assume that everything else is equal, but it is not. The other problem is, so uniformity was our problem. Before that, permanence, stability of measurement was another problem. Now we are going to have separateness. Okay, so I measure a volume of water. And this makes sense if the water is separate, right? So for instance, this volume has width, length, and height. And so I measure the volume of water that is separate. For instance, because it's separated out like this. However, in real life, water is never really separate because it's in equilibrium with all kinds of other waters below it and above it or near to it in the vicinity of something, right? So you can see that this is a highly artificial separation of water, right? But in real life, one volume of water is never equal to another volume of water because the water is not separated out and it is not uniform. You see, volume means a separate entity, that volume of water. But that volume of water is not really separate because it influences, any kind of water near it. It's in equilibrium with it. Okay. And this is what we see on this picture that we already reviewed in the past. So measuring assumes separateness, but there is no separateness. Water may be seen as a grid of separate units, like you see a grid of cubic meters, for instance, okay? And with that, and the grid of clocks, you try to characterize the whole observable universe. But that only works if you have separate uniform entities that are independent of each other. But that is actually not the case, as you see in this picture right here. So objectivity and permanence, stability, always rests on the assumption of separateness and uniformity, which is always virtual. So how can something be objective when it is virtual, when it is artificial? Obviously, anything artificial depends on humans, right? So how can we say that these things are objective? This is a contradiction in terms. I don't see how one can avoid that conclusion. Objectivity is based on abstractions and assumptions, and the assumptions and the abstractions are dependent on humans. So we cannot say that something is objective, meaning it's not dependent on humans, when we set out our measurements and our categories by our human standards. So it's a contradiction in terms. Also, separateness and uniformity makes a whole lot of sense when we talk about artificial things, right? I mean, look at how much these artificial things look alike. Okay, you have fake diversity. You have different shapes and different colors, but there's no real diversity because these things are artificial. They are set up by humans. So therefore, they are artificial. And they are made separate units, countable units, and they are relatively uniform. Whereas these are natural things. Okay, are they really basically and fundamentally separate? These are quite good friends here. They communicate, they influence each other. They're not separate. And they are not uniform. Not at all. So, measuring is a good practical method that is necessary for coordination, cooperation, and community. I mean, surely enough, when I say high fever to you, you understand what my concern is. If my child has a high fever, then obviously it's a concern. And I want to communicate to you that I have a concern by saying my child has a high fever. So I am concerned that this could be a disease that needs to be treated, and please help me treating that disease. Sure, it makes sense. But we need to understand the premises. So for instance, if my child's temperature is 38.4, like 100 degrees Fahrenheit or whatever, but it was 39 2 hours ago, then that means that this is an improvement. So if I fail to communicate that to you and just say that my child's temperature is 38.4, then you do not understand the picture, right? The picture is that the fever is subsiding. The fever is less than it was 2 hours ago or 4 hours ago. Whereas if the temperature is rising, or if a person has a normal blood pressure, but yet the usual blood pressure for him is much higher, then this could mean that the person is now dehydrated, or the person has a very bad infection, okay, because I compare what is to what was before, right? So when I say that there are permanent measures, how permanent are they compared to what? Okay. So instruments and measures also influence things measured. So for instance, if I am a doctor in a white coat and I tell my patients, okay, now this is going to be very important. I check your blood pressure. And if your blood pressure is high, well, I'm going to put you on a medication. Then you might get nervous. And then that blood pressure is going to reflect how nervous you are, not how bad your blood vessels are, which high blood pressure is supposed to be a symptom of. So that if I make you take a blood pressure medication for high blood pressure that I induced by making you nervous, then I treated myself, not you. I treated my influence upon you. And of course, in physics, people were very much surprised that when I measure very, very tiny things, then my measuring instruments are going to influence the measured things. Are you really surprised that they found that? I am surprised that they didn't predict that this would happen. Okay? I do not understand how they thought that their standard instruments is not going to make, under certain circumstances, this kind of influence on that little something that they are measuring, or that kind of influence. We can also reverse this and say that when they were measuring very small things like quantum objects, okay, imaginary quantum objects, then they just noticed more the influence and the changing influence of their measurements and their instruments on that something that they're measuring. But I submit to you that when they are measuring very large things like galaxies, then there is also a bilateral influence there. It's just more difficult to notice that bilaterality, that organic unity of measurer, measurement, and measured things, because you just ignore the bilaterality of that relationship because you imagine something to be very large and something to be very small, and then you think that small things are insignificant. Small things are not insignificant. They would only be insignificant if they were separate, if they were not part of an organic whole. But small things are very significant if they are part of an organic whole. So here we come to a very particular area, and that is interpreting clinical studies in medicine. So first of all, when you make a scientific study, you have to define what kind of populations you are going to characterize or investigate. And that population is then exposed to what and how. What were the comorbidities? How long was your investigation? Where, when, how you measure things? Did you consider all the relevant factors that can influence your measurements? Was there enough statistical power? What kind of statistics you were using? How all these compare to similar studies that had been done? In other words, you see the problems. You measure blood pressure in children. How relevant is that going to be compared to measuring blood pressure in old people? Okay, so now you measure blood pressure in diabetic children versus adults with lupus, for example. So what does it mean to have high blood pressure when you are a diabetic child? And what does it mean to have high blood pressure if you have lupus? Or for instance, maybe you are measuring blood pressure in a population that is exposed to extreme stress or uh, extreme temperatures. Okay, so there are a lot of things that you have to take into account. And when you ignore all these things, then, and of course, there's another thing. Now, imagine that you selected out patients for your studies that are very cooperative. They are enthusiastic about science, or they trust you. That's why they volunteered for your research. Is that going to be the same as somebody in your dialysis unit or your diabetic clinic who is not very cooperative? Not necessarily. So one medication here may act differently to the same medication there. All what I'm saying here, that interpreting clinical studies needs a lot of experience, needs judgment. You need to consider a lot of factors. And when you think that the interpretation of clinical studies is something objective, something standard, no, far from it. Because one researcher considers this, and this, the other researcher considers this, and this, right? And you will need a philosopher to consider a lot of factors and see the big picture. But unfortunately, philosophers nearly never are engaging in such activities, such as interpreting clinical results, except, let me show you about that a little bit later. So let's summarize all of what we said. So we said that in 2023, people are very, very blind, and they breed mind worms because they have certain stuck ideas that they do not think through. And so when the circumstances change, their idea about those ideas do not change. They remain the same. They do not follow changing circumstances. And so they have objective, permanent, absolute ideas that do not follow reality. But we here in Vitologia, we understand that whenever we measure something, the measurement has use, it also has limitations. And we will see the usefulness of that measurement, but also its limitations. We understand that there is a time dynamics. In other words, we went from this kind of temperature to this kind of temperature. We have significance. Well, the temperature changed 0.0001. Is that significant? Or is that significant under certain circumstances because at least it's going down? Is it relative to the precision of our measurement or the instruments? The interaction between measurer and measure. Remember, when I am a scary doctor and I make your blood pressure rise, that's an interaction between the measurer and the measured subject, okay? Precision by scale. You have to have a certain kind of precision for a certain kind of measurement. Obviously, if you measure the relative position of an electron, then you have to be extremely precise, right? There are circumstances and conditions. Okay, so for instance, your blood pressure is high and you are a diabetic, so it's going to mean this. Your blood pressure is high, but you are not a diabetic, so it's going to mean that. Okay? And so, unless you are able, because of your wide horizon, your wide perspective, and your experience, and your good judgment and intuition. So unless you are able to consider a lot of factors and you really see the whole picture, in other words, you are a good doctor. So unless you are, you have to be extremely careful, use caution when drawing conclusions. Okay? So for instance, if you have a decreased kidney function, okay, then you see what the circumstances are. For instance, that person has a diarrhea. So that means, or very often it may mean, that this is a temporary effect of the diarrhea on the kidney. So the kidney is healthy, but the kidney function is temporarily down because of the diarrhea. Now, if you have a high blood pressure, that may reflect that you have a vascular disease, in other words, a disease of your blood vessels, but it may also reflect that you're just simply nervous temporarily, right? So you need to make a difference between kidney function and kidney disease, high blood pressure and vascular disease, blood pressure and high blood pressure and blood vessel disease. Okay? So if you believe that what you measure is independent, objective, like the temperature, and it's in an absolute reference frame so that the temperature exists no matter what, then that is a delusion. That is a mind war. It is not true. Okay? What you are measuring is relative aspects of an organic reality where everything influences everything. The temperature is influenced by what was the temperature 2 minutes ago, okay? Or what your emotional status is, or what the temperature outside is, or a number of factors. Not just the course, the natural course of your viral infection. Same thing with blood pressure, same thing with kidney function. And yet what I see is that people totally fail to recognize this. And then they equate, say, kidney function with kidney disease or blood pressure with blood vessel disease because they do not see the time dynamics and the influencing factors. And then they call things risk factors because they don't understand how things work. And whenever you don't understand how things work, you establish risks. Okay. So here is my diagnosis for 2023 people. And so to demonstrate all of this, I made a little, how to say that, trick. Okay. These are scientific papers, peer-reviewed, high-quality scientific papers that I wrote when I was a little bit younger, partly. And all of these things, all of these papers, all of these scientific reviews say the same thing under different situations in transplantation or dialysis or kidney failure. And that is that one category, one laboratory measurement, one blood work type does not say it all. You have to see the circumstances in which that blood result can be interpreted and all the factors that might influence that blood result. And I also set up a little bit of a course, Nephrology for Patients, to try to explain to them also that if they don't understand that the measurements that they are getting need to be interpreted with caution, then a false diagnosis is going to be made and they are going to be worried for nothing or not worried when they should be. Okay? So with that, I thank you for your attention and goodbye for now.